Last time we just did what is polar. How do we write things in polar equations? What do polar graphs look like? That's all. Okay. Today we're going to do some calculus with it. As a heads up, you're going to write a little bit today. I'm sorry about that, but I'm letting you know ahead of time, and I kept it to one sheet, but this is a little bit of writing. So just, we'll maybe do a break halfway through. All right. Your derivative in polar form, dy dx, is going to be dy d theta over dx d theta. And that should look a little bit familiar to you, or should like sort of trigger something in your memory, because what does that remind you of? Yeah, the last unit we just did, parametric, take two, except instead of theta, it was t, but it's the exact same thing. Okay, so this is not going to be drastically different. And the second derivative works the same way as well. You're going to do the derivative of dy dx. So it's the derivative of the thing you just did. And again, this is instructions that mean take a derivative with respect to theta. It's just theta now instead of t. And then what did we divide by again? Yes, dx d theta. If you say t, that's fine. I will know what you mean. It's the other variable. Okay, so it works the exact same way. Just theta instead of t, not any different. Okay. Horizontal tangent line is a zero slope. That's going to be when dy d theta is zero. That's your numerator. And vertical is whenever you have a zero denominator. So that is going to be when dx d theta equals zero. And again, if you go back and look at your parametric notes, we wrote all of this exactly except with t instead of theta. I wish I could talk today, but theta is like lisping to begin with. So I'm going to make it. So this says find the derivative of r equals cosine theta. First, we're going to find x and y, and this is where this becomes a little bit of writing. Okay. If you remember, and if not, that's fine. We had a 4-day weekend. X equals r cosine theta, and y equals r sine theta. Okay. So if we have r cosine theta, well, r is cosine theta. So if it would be cosine times cosine, I can write cosine squared. And then y is r sine theta. So that would be cosine theta, sine theta. Now we're going to do a derivative. And it is a good bit of writing, but it's not necessarily hard. The rule that you end up using a lot is product rule. So let's just real quick review your question. Yeah. So x is r cosine theta. So I just took r and multiplied it by cosine. That would be cosine times cosine. It's just cosine squared. And y equals r sine theta. So this is r and then times sine theta. We're going to do it a bunch of times on here, so you'll see it again. Okay. Let's review product rule real quick. It's the first thing times derivative of the second plus the second thing derivative of the first. Okay. Y goes in the numerator, x goes in the denominator. That was one issue we had with the parametric. All right. So we're going to look at this one first. So it is going to be first, which is cosine, times derivative of the second. So derivative of sine is cosine, plus the second function, which is sine, and then derivative of the first. So derivative of cosine is negative sine. Perfect. Again, and this is my pep talk for this, it's not hard. It just is a little bit of writing. And then we're going to do derivative for x. This is going to be a chain rule. You're going to bring the 2 down. It's going to drop to a 1. So you can put a 1 there if you want to. You're never going to see that like in a multiple choice kind of situation, but there'll be 1 there. And then you're going to chain on the derivative of cosine, which is negative sine. I'm not interested in doing anything else to that. Is everyone okay with that? No one's like really eager to like manipulate that some more? No, we're going to leave it alone. Okay. Now this next one is find the second derivative of what we just did. This is part B at theta equals 2. This would be a calculator problem, and I don't really have anything to write on the paper. You can make a note to yourself of how I'm typing it if you want, but I'm going to go to the calculator and show you how to type it in. Okay. So everyone just pay attention and we'll type it in together. And you guys can check me if I make a mistake. Now, when I'm typing in the calculator, I like to use x instead of theta. Is that okay with everybody? Yeah. If you do want a theta, I just spell it theta, and it'll come up. Like, here, let me show you. If you do want theta, you see that? How you spell it, it'll just come up. But I'm going to just put x, right? So I'm going to make f of x be the derivative we just got. Cool? All right, the thing that we just did. So it was cosine times cosine. And then what was next? Plus sine times negative sine. Cool. All right, you're coming with me on this. Just make sure everybody's with me. And then I'm going to divide all of that by, yeah, can I put the -2 out front? Is that okay with everybody? -2. I know this is not super fun to watch your teacher typing this. This is kind of how it works, all right? I messed something up though, didn't I? I just bumped the C. I will not conceal from you. I have much disdain for calculator problems. It's just like, here, let's just hit a bunch of buttons, right? Anyway, that's the derivative we just found. We want to do the derivative of that. So what am I going to type in the next box? Yeah, f prime of, and then they gave us a number there. We want f prime of 2. Okay, so f prime of 2. It's got to be a value. And I guarantee you, if it is a multiple choice question, that is going to be one of the wrong answers. I guarantee it. All right, because you have to take that and divide it by dx d theta again. So it's -2. Now on there we have cosine theta, sine theta, but I want it to be cosine of 2, sine of 2. So you have to divide it again. So that's your answer, 4.614. I don't really have any notes to write on the paper for that. So if you want to like jot a note to self about how we got that, because it purely happened within the calculator, however it works best in your brain to remember how we typed that. But that is the answer. So you do the derivative of what you just did, divide by dx d theta again. And I just chose to type x instead of theta because I am lazy. All right, I'm going to do it again. Find the derivative of r equals tangent theta. So the first thing we're going to do is find x and y. Oh, yeah, 4.614. So x is going to be r cosine theta. So it's going to be tangent times cosine. And then y is going to be r sine theta. So tangent times sine. You just take whatever r is, multiply it by cosine, multiply it by sine. This one, I can't really do anything to. This one, I'm going to clean up a little bit. Does anyone remember how you can rewrite tangent? I just want to throw it out there. If not, I'm going to tell sine over cosine. So I'm going to rewrite that as, oh, and I forgot a theta, which is bad. Sine over cosine, because what's going to happen? Yeah, they divide out, and you just get sine theta, which is going to be easier to work with. I won't have to do a product rule. So I just did those couple of little steps to cancel out so that when I do my derivative, it's not as much writing. So dy dx, we're going to do derivative of y over derivative of x. So here's y. It's a product rule. Almost all of them are going to be product rules. All right. So the first function, tangent theta, times derivative of the second, which would be cosine, plus the second function times derivative of the first. If you want to write pst on your paper, remember PSST, P is positive. You cover up the one you want. It's going to give you the other one. Derivative of tangent is secant squared. Good job. I always say the issue with Calc BC is not any one topic being difficult. It's the sheer quantity of things you have to memorize. I always say that. It's true. Over derivative for x, derivative of sine is cosine. And see how easy that was? I think it's beneficial if you can, simplify a little bit. All right, so this one says find the coordinates of horizontal tangent lines. Does that mean we want to be looking at x or y? Y, all right? So y equals r sine theta. R is sine, so it's going to be sine squared of theta. Cool. So dy d theta equals, it's a chain rule. You're going to bring the 2 down. It's going to drop to a 1. You can write a 1 if you want to. And then you chain on what? Cosine. Derivative of sine is cosine. Oh, you're all hanging in there. Nice. And we're going to set that equal to 0. Cool. This is where we're going to need our unit circle. 2 equals 0 doesn't make any sense. The other way you can think of that is 0 divided by 2 is still just 0. So I'm going to ignore that, essentially, that coefficient out front. We're going to set sine equal to 0 and cosine equal to 0. And we're going to kind of imagine our unit circle, but we're going to be aware of our interval here so that we don't go too far. Because you could go around and around and around and around and get thousands of answers, an infinite number of answers, really. We want to stop it at some point, all right? So sine is going to be 0 at what angle? 0. And I like to put pi with it, like no pi. The next one would be 1 pi, but I'm not going to use that. Why not? Yeah, it's not equal to there. We're stopping before we get to pi, right? Cosine is going to be 0 when your angle is pi over 2. The next one would be 3 pi over 2, and that's off of our interval, right? Now, the directions said to write it in both rectangular and polar. All right, so let's do polar first, since we have our thetas right there. It is r comma theta. So if you want to go ahead and set it up, because I really feel the theta should go first. I don't know. I feel strongly about that because we're going to plug theta in. It's like you plug in theta and get r. It should be the other way around. I'm going to start a mutiny. You're going to plug this into r. So if you plug in 0 pi to our r right here, you would just get 0. And so if you plot that point, it's at the origin, or it's also called the pole, right? And then if you plug in pi over 2, 1. And then we're going to do rectangular. In this case, I would just think about where they fall, because these are going to fall on the axes. This point would just be 0, 0. Now let's think about this one. You would go to pi over 2, which is up at the top, and 1 unit away. So in rectangular, that would be 0, 1. It's actually on the unit circle. Do you want to hang in there for one more and then we'll do a break, or do you need a break now? I realize this is a lot of writing. But hang in there for one more. One more? All right. So this one says vertical tangent lines. That means we want to look at x. Cool. So x is r cosine theta. I made r a little bit more complicated in this one. All right. What I would do personally first is I would distribute this 2 through there. All right. If you distribute the 2, you're going to get 2 minus 2 cosine theta. Okay. So x equals that times cosine. R cosine theta. Okay. Nervous where this is going. It's not going to be drastically different from the one we just did. It's just a little bit more complicated. Okay. Because R is a little bit more complex there. All right, so we're going to do dx d theta. It's going to be a product rule. All right, so just buckle up. It's going to be the first function. You're doing a lot of recopying. You can do it. I'll just keep pep talking. You guys have got this. You're doing excellent. I'm proud of all of you. This is great. I'm not just saying that. Like, you're doing an awesome job. All right, first times derivative of the second, which would be negative sine. Cool. Plus the second function. Oops. I just drew another parenthesis. All right, the second function times derivative of the first. All right, so we're doing derivative of this thing. 2 is a constant, so that's gone. Derivative of cosine would be negative sine, so the negatives are going to cancel. It'll be positive, good, 2 sine theta. And we want to set this equal to 0 for our vertical tangent line. So here's what I would do next. I would take this negative sine theta and distribute into these parentheses. It's not hard. It's just a little bit of writing. You've got this. All right. If you distribute to just the 2, that's going to give you negative 2 sine theta. Got it? You got it. If you distribute here, the negatives are going to cancel. So it's going to be plus 2 cosine theta sine theta. Good job. Now, what does that next thing say? This is plus 2 cosine theta sine theta. So if you have 2 of that thing plus 2 more, you now have 4. And already it looks not as scary. We shortened it, a good bit. In the math we did, there was 2 plus 2 equals 4. The next step is factoring. I realize it's been a while since Algebra 2, and I realize that Algebra 2, you didn't have a teacher for a lot of the class. So I'm going to just do a sticky note problem real quick. Can you just pay attention? We'll just do a sticky note problem. We're going to review GCF, all right? Let's say you have 50 minus 15, or let's throw an x in there for good measure, x cubed. How would you do a GCF? What do they share in common that you could divide out? All right, 5x, good. And then you're undistributing. So in parentheses, you're going to put what's left, which would be 10 minus 3x squared. And if you were setting this equal to 0, you would then set 5x equal to 0 and this whole thing equal to, you see what I'm saying? All right, we're going to do that, but with sines and cosines. So we're going to look at both of these and decide what do they share in common. So what can I divide out of both? Now, are you okay with me taking a -2? Is that okay? I'm going to take the negative, and I can also take sine. Good. Okay, cool. That went well. And then in parentheses, we're going to put what's left. Now, from the first part, we took everything. Perfect. Now here, it's 4 divided by -2. So -2. And then we also divided out a sine, so you're just left with cosine. Cool. You guys hung in there. Nice job. And then you're going to set this first factor equal to 0 and the second factor equal to 0. I'm running out of space, so I'm going to just kind of talk you through this first one. If you set sine equal to 0, what's your first angle? Because we kind of did this one on the other side of the paper. First angle is going to be 0, and I like to put pi with that. But I think we can go further based on our interval, pi. The next one would be 2 pi, but I think we stopped just short of that, right? Yeah. Okay. Now this one, if you set this equal to 0, you would subtract over the 1, it'd be a -1, and then you would divide by, there we go, -2. So the negatives are going to cancel, and you're going to get a half. I want you to look at your little cheat sheet, or just think about it. There are 2 angles where cosine is a half. One is in quadrant 1, the other one's in quadrant 4, because that's the other place where your x value is positive. So see if you can find one in quadrant 1 and quadrant 4. They're both going to be pi over something. Something pi over something. Pi over 3 is the first one. Good job. And the other one's in the 4th quadrant. I'll answer that in a second. So that's over 6. It's the other one. But you're doing it without your cheat sheet, so that's impressive. It's 5 pi over 3 because I have to answer this phone. Hold on a second. All right, we are actually going to get rid of this one. And let me show you why. Let me show you the graph for this. I have to exit full screen to make it show the graph. Do you remember how to type in things in Polar? Did we go over that? Yeah. So let me see. Oh, let me get rid of that mess. I'm going to come over here to my grid. Oh, not that. I don't want to change the language. I'm going to change it to Polar, and I'm going to put R equals, what was R? 2 minus 2 cosine theta. So this is what it looks like. What was the question asking us for in the first place, like way back when? Vertical tangent lines. You can't get one at 0. Why not? Undefined. You can't get a derivative there at all. Do you remember not differentiable due to sharp edge? Okay, so we're going to throw that one out. What are the other ones we got? Pi is this one here. Do you see how there would be a vertical tangent line? All right. This is called a cardioid. It looks like a heart. And then this is the pi over 3 right there. And then 5 pi over 3. Do you see that visually? I think it helps to look at it visually. All right, but we're going to throw out that one. Now, did it say to write the answers in polar or rectangular? Go. Polar. 0. There was a sharp edge there, a cusp. So you can't get a derivative there. And then what's the next one? Pi over 3, and then 5 pi over 3. So set them up blank. Otherwise, you're liable to put the theta first. I always want to write theta comma r. So if I set it up blank, that helps me remember. And you're just going to take these and plug them into r and see what you get. So if you plug in pi, cosine of pi, close? Colder. -1. There you go. Pi is on this side of your unit circle. Cosine is the x part. That's -1 times -2 would be 2, and then 2 plus 2 is 4. Cosine of pi over 3 is a half. A half of 2 is 1, and then 2 minus 1 is 1. And this one's going to turn out the same, which I showed you on the graph, how they were in the same place. All right, this one is asking for what? Just read it. Okay, so what two things do you need to write an equation? All right, a point and a slope. So we're going to need to get x and y. X is r cosine theta. So that would be 2 cosine theta times cosine. So it would be 2 cosine squared. Good job. And then y is r sine theta. Should look like that. So first we're going to get our point. We're going to plug in 5 pi over 6 for theta to both of these to get our point. So if you want to pull up your cheat sheet and look at the triangle for 5 pi over 6, it's in quadrant 2. Okay. Cosine, which is the x value for 5 pi over 6. Can you find it? Good. So you have 2 times that squared. So first of all, if you square a negative number, it's going to turn positive. And then we're just going to square these. Square root of 3 squared is just 3. 2 squared is 4. When you square a negative, it turns positive. Yeah. Like if you have negative a half times negative a half, you're going to get positive a fourth. This one just looks funny because there's a square root in it. All right, if you want to put the 2 over a 1, if that helps you, you're going to multiply the numerators, multiply the denominators. It would come out to 6/4, which is 3 halves. Cool. We're going to do the same thing for y. So we're going to have 2 times cosine of 5 pi over 6. You guys just told me it's negative square root of 3 over 2. What is sine for 5 pi over 6? It's 1/2. Good job. All right, so these are going to divide out, the 1/2 and the 2. And so you just get negative square root of 3 over 2. I don't like how that looks. It ran into my parenthesis. I'm going to make it look prettier. Where does slope come from? Derivative. So buckle up. I know. It's a lot. I told you when we started. Okay. So which one do we do on the numerator? X or y? Y. Okay. So we're going to do the first function, which is 2 cosine theta. I'm going to group the 2 with the cosine. That's our first function. Derivative of the second cosine plus the second function, and then derivative of the first. Hold on one second. Derivative of cosine would be negative sine, so it is -2 sine theta. All right, while I'm answering the door and getting them their stuff, can you try and do the derivative for x? Well, you already have the papers because you came and got them. Hold here for 1 second. Hey, I did give you a task to do while I answered the door. All right, these are your papers from last class and today. Thank you. Thank you. All right, what do we get for our derivative for x? You bring the 2 down, it'll be 4 cosine theta times negative sine theta. I'm going to put the negative out front. Derivative of cosine gives you negative sine. Now we're going to plug in 5 pi over 6 to that to get our slope. You're not going to like this. Okay, but we're going to get through it together. All right, so in the numerator, we've got a 2 What did we say was cosine of 5 pi over 6? Yep, so negative square root of 3 over 2, and then again, negative square root of 3 over 2. Instead of plus, can I put minus for this negative here? Is everybody okay with that? If I move the negative in front, because it's subtraction. All right, minus, what did we say sine of 5 pi over 6 was? That's 1/2. And then we've got a 2 in there, and then another 1/2. Over negative 4 times negative square root of 3 over 2 times 1/2. My pep talk for this is, because I know you're like, I hate everything right now. It's the same numbers over and over again. Okay, and that's how the unit circle works. It is the same numbers over and over again. And also a lot of stuff is going to divide out. Okay, like first of all, I notice I have a 1/2 times a 2 here. Do you see that? Let's just go ahead and get rid of those. Also here, I can cancel out one pair of those, or divide out one pair of those 2's. Okay, so let's see what that leaves us with. Negatives cancel. This will be positive 3, and then I still have that over 2. All right, minus, all that's left there is 1/2. Down here, negatives cancel. What would that be? 4 square root of 3, over 4. So the 4's actually cancel as well, and it's just square root of 3. Almost there. We almost got it, all right? 3/2 minus 1/2 would just be 1, right? So there we got 1 over square root of 3. Now, if they're extra evil and it's multiple choice and they rationalize that, rationalized, it would be square root of 3 over 3, just for the sake of being thorough, so you could, make sure you pick the right answer. So that is your slope, and then you put it together and write your answer. Here's your point, here's your slope. Final answer would be y plus square root of 3 over 2 equals square root of 3 over 3, parentheses, x minus 3/2. Good job. Hung in there. Nice. Made it through. Last one. And we're still good on time. You guys are awesome. All right, last one. And I don't appreciate that. And I did hear you. And now that's on my recording. Find the value of theta, and we're going from 0 to pi over 2. Oh, look, it's including pi over 2 this time. That corresponds to the point on, here's our equation, r equals all of this, smallest distance. That means absolute what? Smallest means minimum. Absolute minimum. What test do we use for absolute maximums and minimums? It's your candidate's test, okay? So let's just even go ahead and set up a table right away. Your candidates are who? 0 and pi over 2, and I like to put the pi. So those are your end points. What are your other candidates, or how are we going to get them? Derivative equals 0. Now, the good thing about this one is we don't have to get x and y because we're only using r and theta. So we can actually just go ahead and do r prime as is, and you don't have to find x and y. So that's kind of a blessing there, all right? 5 is a constant, so that's gone. But we are going to have to do a product rule. Your first function, actually, I didn't leave enough room for a product rule. I'm going to have to scooch this over. I'm going to need more space to do a product rule. So your first function is that negative 4 theta. So that's first thing, times derivative of the second. What rule is that? Good. Perfect. Derivative of cosine is negative sine, and you'll need to chain on a 3. So that's first derivative of the second plus the second function. Derivative of the first would simply be negative 4. I have more good news since we got through that. What does it say in the directions here to round to? 1,000. That means we get to use what? All right. So the rest of this is going to kind of happen within the calculator. So I need for you to watch, pay attention, and write yourself a note if you feel like you're going to need to remember how this gets typed. So what I am going to do is write f of x. I realize it's r of theta, but I'm going to write f of it's r prime, but I'm going to write f of x. And then I'm going to just type all of that. I want you guys to watch and tell me if I type something wrong. Because if I type something wrong, this whole thing is not going to work. Did that go okay? Okay. Now, there are a lot of places where this equals 0. Do you see all of these? Like all these places it touches the x-axis? How do I know which ones I want? Well, I have to stay between 0 and pi over 2. Pi over 2 is 1.57. So we're going to get all the ones in between 0 and 1.57. So here's the first one, 0.378. We're going to put that on our table. And I'm going to export the point so that I can copy paste it. And then do I want, I feel like I typed something wrong because that's not what, I did type something wrong. No, actually, I wrote it wrong on my paper. Dang. You know what? I'm a human being and I made a mistake. I was like, these numbers are coming out bigger than I expected them to. I'm going to have to go and fix it. Actually, I'll see if you guys can find it. It's somewhere in here. What did I mess up? Derivative of, I said it out loud when I said it, but I didn't write it. It would be -3 sine of, and what did I write? I did. I don't mind when that happens though. I mean, I feel a little embarrassed, but all I did was miss a 3. And that illustrates how easy it is to get something drastically wrong if all you miss is a 3, okay? So it doesn't bother me that much. I try to be as perfect as I can for you, but like you've never seen a teacher make a mistake, right? None of you caught it either, so. All right, let me go back and fix this. All right, so what do I need to fix in here? I need to fix, put a 3 in there. Where's my cursor? Did I lose it? Where's my cursor? It's just being slow. There we go. Okay, so this point is wrong. There we go. That looks more like what I was expecting it to. All right, so we want all the values in between 0 and pi over 2. So here's our first one, 0.286. That sounds a little bit better. So put that on your table, 0.286. And then let me get the next one, because I think that one, I think there were two. 1.141. I'm going to export both of those points. I think the next one is outside of the interval. If I click on this next one, 2.4, I mean, obviously that's going to be beyond 1.57. So I'm going to get rid of this. Okay. Now I need to take all of those values and plug them into what? What's the other half of our table say? We have theta and then we have r. Okay. So our r is, you know what? I'm going to make this easy. I'm going to call this one g of x. Do you know why I called it g instead of f? The other one's f. All right, I'm going to just type in what r is. 5 minus 4x cosine of 3x. I'm just going to make this easy. All right, what's the first one we want to do? 0, right? All right, 5. Put that in your table. The next one, I want to copy and paste this point. Come back here. .251. All right, and then I'm going to copy and paste this point. At this point, I forgot what we were supposed to find. Can anyone reread it? Did we want maximum or minimum? I think it was minimum, wasn't it? Absolute. Absolute minimum. All right, that one's 9.384. And then the last one, I'm going to plug in 5 or 2, which is, 5. Sweet. So now we get to write our answer. Out of all of those R values that we got, what is the smallest one? All right, our absolute minimum is 4.251 at theta equals 0.286. And your justification is the table.